Hi, my name is Peyton Chandarana. I'm a PhD student in the iCAS lab under the supervision of Dr. Ramtin Zand at the University of South Carolina. Today, I'll be demonstrating our work on real-time facial expression recognition for intuitive robot coaches. To benchmark our facial expression recognition models, we use 3 different edge devices. The first device we use is the NVIDIA Jetson Nano. The Jetson Nano is a smaller GPU in an edge form factor that totals 128 CUDA cores distributed across its 4 CUDA blocks. It has 4 gigabytes of memory and 2 different operating modes, a low power mode and a high power mode, and supports frequencies from 0.64 GHz to 1.5 GHz. It supports 32 and 16-bit floating point operations, and utilizes NVIDIA's TensorRT library for optimizing ML models. The next device we use in our benchmarks is the Google Coral Edge TPU. This device comes in 2 different form factors, a development board and a USB-C form factor. The development board has a quad-core ARM CPU, as well as up to 4 gigabytes of memory. All models that we used were quantized to 8-bit integers and deployed on the devices using the TensorFlow Lite library. In our demo, we'll be showing the USB-C TPU working. Another device we used for our facial expression recognition models is the Neural Compute Stick 2. This device is based on the Movidius X Vision Processing Unit, or VPU, a 700 MHz base clock, along with 4 gigs of memory, and a 16 nanometer technology node. It only uses 16-bit floating point operations, and in order to get models to run on it, you have to first convert them with the OpenVINO toolkit. And now we'll demonstrate our facial expression recognition models running on the Intel Neural Compute Stick and Coral Edge TPU by my fellow PhD student in the iCAS lab, Mohammadreza Mohammadi. He'll show several different facial expressions, including anger, surprised, and happiness, and the 2 devices you see on screen will classify and recognize these facial expressions in real time. Here we have 2 different setups with a Raspberry Pi and USB edge accelerators. One has the Neural Compute Stick on the left, and the other one has the Google Coral Edge TPU on the right. Here we're showing that there's an emoji with the classified facial expression of Mohammadreza. Right now he's happy, and you can notice that the Neural Compute Stick is in general a lot slower, averaging around 3 milliseconds to classify his facial expression. Here we're showing about 3 different classes, happy, angry, and surprised, which he's showing right now. Next, we demo the Coral Edge TPU setup with the Raspberry Pi and the USB form factor, showing again the same emotions, but you can notice that the Coral Edge TPU in general is much faster when it comes to classifying him, averaging under a millisecond. And again, it kind of looks like the Coral Edge TPU is slightly more accurate as well. So why do we care about facial expression recognition in this case, and why do we care about it at the edge, specifically with a Raspberry Pi and edge accelerators connected to those Raspberry Pis? Well, we started a collaboration with Zand Robotics, which has a social emotional learning robot called ABii, which interacts with students to provide a positive learning environment. Specifically, ABii tries to encourage students to have a positive attitude towards learning in subjects like math and the sciences. ABii also does some posing and dancing to kind of make the environment fun. Specifically, ABii uses a Raspberry Pi to compute and do all of its interactive motions, posing, and processing. So our plan is to take one of the edge accelerators that we previously mentioned, either the Intel Neural Compute Stick or the Edge TPU, connected to ABii, and then have real-time facial expression recognition on ABii to help give students interactive feedback when they maybe are having a little bit of trouble with certain topics, and encourage them to do well, and maybe even help them enjoy and be more positive about the experience. And our plan is at this conference, we're going to integrate these systems. We're going to take the Edge accelerator, get it working with ABii, and have ABii in real time classify facial expression recognitions and interact with the audience. Thank you very much.